Okay, see Lindelof videos. Solve trig functions using difference of squares. This function looks like crap, but we can definitely do this. This is cosecant to the fourth power 2u minus 4 is equal to 0 on the interval 0 to 2 pi. And this is the half open interval here. I'm looking at this and I'm trying to figure out exactly how and when I want it is. I'm going to use u substitution somewhere, and I haven't really decided where, so I guess I'm just going to leave it for this second. First thing I'm going to do is I'm going to notice that this is difference of squares. And this is difference of squares because cosecant squared to u squared is this. This negative sign is this one, and 2 squared is that. So I have difference of squares, and we know that difference of squared is a squared minus b squared can be rewritten as a minus b times a plus b. So I'm going to use that little piece of algebra there. And I'm going to break this thing out, and I'm going to say that I have cosecant squared 2u minus 2 times cosecant squared, I always do that, cosecant squared 2u plus 2 is equal to 0, equals 0, equals 0, right? I'm going to go through this. This looks like crap, but we're going to get a big bump here because this one is non-solvable. If you think about this, right? There's no solution here. And if you follow this out and try to solve it, you'll see that the whole thing gets set equal to the square root of negative 2, and we know that's not real. So that's not real. So we don't have to pursue that any further. We can just stop there. That leaves us with this. That leaves us with cosecant squared 2u minus 2 equals 0. If you don't mind, what I am going to do here for a second is just clean up this picture a little bit for myself. So what I'm going to do is use a little u substitution. I'm going to set let 2u equal theta. It just helps me to get my picture a little bit more clear in my head. I'm going to have to come back and resubstitute this, but for now, I'm just going to leave this. So I'm going to say cosecant squared theta minus 2 is equal to 0. So that gets me somewhere. Start to solve this, and we'll get cosecant squared theta is equal to 2. I just added 2 to both sides. Take the square root of both sides, right? Take the square root of both sides and get cosecant theta is equal to the square root of 2, which I think works pretty good. Oh, you know what? I have to be careful. I took the square root of something here, so it's plus or minus. That's really, really important to us because it's going to mean there are more answers on the unit circle. The next thing I'm going to do, and you're going to have to stay with me on this, I realize that cosecant is 1 over sine theta. So I'm going to say 1 over sine theta. 1 over sine theta is the replacement. It's the reciprocal value. If you look at your fundamental identities of trigonometry, we can replace this. So I'm just going to use this replacement value. It's a lot easier for me. Is equal to plus or minus the square root of 2. I'm going to do a little bit of algebra, and I'm going to solve for sine theta. And we get that, right? Little algebra here, so you have to apply your own algebra. Little algebra here, we get sine theta is equal to plus or minus 1 over square root 2. If you solve this out, right, these are reciprocal, the algebra, just do the algebra, right? So I'm like, okay, this sucks because this you have to kind of know from math that we are not allowed to have a radical in the denominator. So we have to rationalize that by multiplying by square root 2 over square root 2. Don't get freaked out. Like, this can definitely be done. Ends up being square root 2 over 2, right? Square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2, so we get that. And remember, it's plus or minus. Holy crap, right? So now what we have to do is say this. Now we have to go to the unit circle. And at the unit circle, we have to look, right? We have to look for square root of 2 over 2, plus or minus square root of 2 over 2. So plus or minus square root of 2 over 2. I'm going to go to the unit circle and we'll find these things together. So we go to the unit circle and we need sine, right? So sine is square root 2 over 2, which is pi fourths, right? There's pi fourths right here. And we see that its sine value is this. We go straight across, and we see that it has a similar sign value. So it's square root 3 over 4, 3 pi over 4. Wow. And then down here, 5 pi fourths, isn't it? So 5 pi fourths. Then over here, this also has that sign value. So 7 pi fourths has the same 7 pi fourths. This is the part people get confused on. They're back here, and they're like, where the hell am I going to go from here? So now we found those theta values that make that true. That sine of pi fourths is equal to this. Sine of 3 pi fourths. So now I have to set it up this way. I have to say theta is equal to pi fourths. Check this out. It's horrible. Plus 2 pi, because if we go around the circle, 2 pi in. If we go around the circle, we get back to that, don't we? And also, theta is equal to 3 pi fourths plus 2 pi n. I know somebody's looking at this 2 pi n and getting freaked out. 2 pi is one time around the circle, so no matter where you are from here, if you go all the way around the circle, you get back to here. If you start here, you go around the circle, you get back to here, don't you? So that's what that's for. N is any integer. N equals any integer. That just is a machine that takes us around the circle as many times as we need to go. So theta equals that. Theta equals 5 pi fourths plus 2 pi n. And lastly, theta equals 7 pi fourths plus 2 pi n. And you're like, thank God, we're done. Yeah, but we're not, because we have to go back. And remember, we traded in this value to keep us from getting too confused. And it says, let 2u equal theta. And therefore, we have to go back and say theta equals 2u. So 2u equals pi fourths plus 2 pi n. When you solve for u, you get u is equal to pi eighths plus pi n. And you do the same thing here, the same thing here, and the same thing here, and you get your answers. So I hope this video is helpful. I know it's a pain, but this can definitely be done. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. Thanks.